Thanks everybody for joining. The session today is going to be around the JSON and XML parsers. Ulrike, could you give me a presenter, please? Thanks. So these parsers are very different to the awk parser. The awk parser is meant to parse largely unstructured text that is just flowing in, and you're going through it line by line. Kind of like a human goes through a document. The JSON and XML parsers are meant to parse essentially hierarchical data. Both JSON and XML are hierarchical data structures, and the parser is built for that. One of the differences between the JSON and XML parsers and the awk one is that this parser was completely invented by us. So on the one hand, it's very focused towards what we try to do at Indani and what the technology is trying to do. But on the other hand, it's a completely invented language. So sometimes the learning curve is a bit more steep and a bit more difficult. In our experience, we've seen that it takes a bit more time to pick up the JSON and XML parsers than it is for the awk parsers. It takes a bit more time to think about them the way they actually work. But once you do, and once you're on top of it, you can have very good control of what you want to achieve, and it becomes very powerful. So now let's think about the need for a moment. I'm going to share my screen over here. So let's think about the need for a moment. So let's say I'm working on supporting Palo Alto networks. In Palo Alto networks, you can grab data through an API that they invented, which is not exactly a REST API, and is not exactly a SOAP API. It's just kind of a different API structure. And the output from the API is XML. So for example, here is an API call, and the API call says, I want to run show admins, okay? And I'm providing an API key. And the output of this, can you guys see what I'm seeing? Yeah? Okay. So the output of this, it looks like this, okay? It's an XML. Now, in this specific case, the XML is not well formatted, so it's a bit difficult to track. But if you look at an online XML viewer, I try to just use one of these. Just pick one that you like and would be easier for you. But what you can do is you can format it, and then it's a bit easier to see. So you can see there's a hierarchy here, okay? So there's the response, within it there's result, admins, entry, et cetera, et cetera. This is very, very important to take note of, because that's essentially the entire way our parsing works. Remember that any XML can only have one root element, so only one element at the bottom of the hierarchy. That element can contain whatever number of elements, and those elements can contain whatever number of elements they want to contain, but there's only one root. Okay. Now, in the specific example here, what we want to do is iterate over each of these entries under the admins and pull data pertaining to these fields. Okay, that's what we're trying to achieve here. An important tool with XML is called Xpath. So let's see, does this tool? No, it doesn't. Okay, so we'll do this Xpath online. So Xpath is a language used to traverse XML data. So if we take that XML that we just had, an example would be I want to start from the root, okay, response. Then I want to go into results, then admins, and then I want every single entry. Okay, this is the Xpath language. The training today won't talk about the Xpath language as a training for that, because there are a lot of online resources for training on the Xpath expression. And you can kind of dig into those, but it's important to realize that we use Xpath heavily because that is the standard for navigating XML content. If I run tests, you'll see that it runs the test, and you can see that it found my Xpath found two elements. This is one, and this is the other. Okay. A resource I found to be very useful for Xpath is Xpath MSDN. They have basically these different pages on the MSDN site, so it's the Microsoft site. It's pretty good with explaining how Xpath works, a bunch of examples, syntax functions you can use, things like that. This is very, very useful, their documentation. So I highly recommend looking into that and getting to know it. And you'll notice things like the asterisk here or double slash or things like that. More advanced things essentially, and you're going to see the use of some of these within our existing IND scripts. So it would be if the device you're set to support has XML output, it would be a very good idea to get familiar with this thing. Okay. JSON looks like this. F5 is big IQ. Yeah, big IQ. JSON looks like this. Okay. You'll notice it's hierarchical, just like XML, but it tries to be more shorthand in the amount of text you need to write to actually be able to describe a JSON structure. And also, it just tries to make things a lot simpler and simpler to read as well for humans, for us humans. So you can see that there's a root here, right? It gets opened here and it gets closed somewhere down here. Here. Okay. Ignore the rest part. I'm not going to get into that at the moment, but essentially this is the end of the root. And then within it, you have sets of keys and values, they call it. This is a key. This is a value. The value can be a number. It can be a string. This is a string if it has quotes. Or it can be an array. These square brackets are arrays. Okay, so for example, here, this is an array of slots. Now it happens to have just one slot, but I'm sure there are examples here of arrays that have multiple, like here. No, that doesn't. Let's see. Well, this is an array actually, if you think about it, because it has this key, and then under it there is an array with 3 elements. Okay. So if the device you're working with has JSON output, it's important to learn JSON. So essentially spend the time to look at JSON. Now, remember we have Xpath for XML. Okay. For JSON, you have Json Path. Okay. And Json Path is very different to Xpath. So other than the name, there's no other similarity between them. Okay. So if you're writing a JSON, just don't assume that they're similar in any way, shape, or form. If you look at this as an example, this is the JSON test content, and the JSON path is I want to start from the roots. That's the $sign. Then I want to go into the phone numbers, and I want to get only the first one. Okay, this means I want only the first one, and I want to get the type of the first one. Okay, I could write something like this, and then I'm going to get, shoot, what did I get wrong? Then I get the last one, sorry, because it's supposed to start from 0. If I do 0 to 999, then I get all of them. See the evaluation? This little website, super useful. The guy who wrote the F5 content, I think, spent most of his days working with this thing. So find the online evaluator you like for these two technologies. I mean, the one here for Xpath is not amazing. There's some better ones out there, but find one that you find that is very comfortable for you, and stick to it. It's going to be very helpful for you, because anything you want to build from a path perspective, it's easiest to first figure out the Xpath or the Json path. Now, to make matters even slightly more complicated, there is it here? Oh, it's not this one. Okay, so it's not here. I need to find it later. But to make things slightly more complicated, the implementation of Json Path in Java is slightly different to the global implementation of Json Path. So there are certain functions that exist in the global one and not in this one, and vice versa. There was a website that listed that I can try to look for. I think it's J-Way, if I'm not mistaken. Here, this. Okay, this is a better JSON path evaluator for the Indeni platform because we specifically use the JSON Path library in Java. And like I mentioned, it's slightly different to the main one. So if you're using a JSON Path evaluator, it's better to use this one, jsonpath.herokuapp.com, and not jsonpath.com. This was slightly misleading, and sometimes it looks better, and 99% of the times the results are the same, but we just noticed that sometimes they weren't exactly the same. And you can see that they actually let you compare different implementations of JSON Path, but stick to JWay. Okay, so summarize. XML, JSON, they're both hierarchical data structures. You need to know which one is which being used by the product you're supporting. Sometimes they would actually use both of them. Before you get into them, make sure you do the tutorials of XML and JSON, or whichever language, and then get very comfortable with the path terminology, the Xpath here, or JSON Path for JSON. Okay? So now let's talk a bit about the parser in our world. Once you nail down the path, you're going to use the parser in order to generate metrics. So, as a reminder, metrics are essentially the units of data that we use to essentially store data about what's happening in devices and then run rules on top of them. So the JSON Path parser, the JSON parser and the XML parser are very, very similar. Actually, we can stick to this example. The structure is as follows. It has operators that have an underscore. So whenever you're seeing an underscore in the beginning, this is a reserved operator, essentially an operator we invented in our language. And these operators are used to take certain actions or to describe certain structures within the parser. The underscore metrics is the most known operator, and generally you have only one of them in a script. This operator says that everything under this are essentially metrics that I want to generate from the script. Some of the metrics are just individual metrics, and some of these metrics would be multiple metrics with a variation in tags, which we'll get to in a second. Under the metrics operator, you're going to see this funky symbol. Now, the structure of this language is called YAML. So this, YAML. Okay? YAML is like XML, but more human readable. Okay? We use YAML in all kinds of different elements of our code. And in the case of the JSON XML parsers, YAML is the syntax we use for describing the parsers. Now, YAML is very straightforward. It basically has a structure, a hierarchical structure, and it just follows that. A couple of things to notice with YAML is that it's very, very sensitive to the number of spaces you have here. Our standard is just having 4 spaces, so you just hit the space bar 4 times. Do not use the tab button. YAML does not like tabs, so you need to stick to spaces. 4 spaces is the structure. So you'll notice this is 4, and then this is 8, and then this is 12. If you make the mistake of not having the right number of spaces, YAML will get confused with the hierarchy, because if I have this, for example, and this has 8 spaces, and this has 7 or 9 spaces, the YAML parser is going to assume that these are at 2 different levels of hierarchy, whereas we actually mean for them to be at the same level. So spaces are important. Okay. Now, each of the metrics is separated by this little hyphen. So this is one metric, and this is another metric. Okay, so every metric starts its section with this little hyphen. Okay. Metrics have values, and they have tags. Okay. The most basic tags all metrics have is im.name. im.name is the name of the metric. Okay. In the awk parser, it's the equivalent of this. So when you write a metric in the awk parser, you see this, the first parameter we pass, which is the name of the metric, that's the same thing. Okay. What's actually happening in the backend here is that it's adding a tag called im.name equals water level. That's what the function's doing. Okay. So the tag IAmName and the value itself is arc total entries. Notice the operator here. Okay. Underscore constant means just use the string as is. Okay. There are other operators that we're going to talk about in a second, but that's the simple operator that says just use it as is. Okay. Notice that YAML has a structure where everything is key value except for hierarchy. Okay. You're never going to have a situation where there's just an operator here and nothing after it. Okay. If you have something like it, then it's going to be like this, where it's essentially opening a hierarchy level. Okay, but you're never going to have just a simple key and no value and no hierarchy that's being opened. YAML will not let you do that. Okay. Commenting is with this hash sign, and you can put the comment after. This is the same as awk. Makes it a lot easier to read the code afterwards. The value part talks about the value that the metric has. We have two types of metrics, double and complex. Double are just numbers. Complex are JSON structures, which we'll talk about. The value operator has to exist in every single metric we create. You can never create a metric without a value operator. Okay? So we have double, we have complex. Under the value operator, depending on the type of value that it is, you're going to have the value itself. Okay? This value says the value of, so it looks a bit funky if you look at it, but the value of the metric is a double. The value of the metric is going to be the value of evaluating just this JSON path. So this underscore value, and this underscore value are completely different operators. Okay, this one says I'm now going to define how I set the value of the metric, whereas this one says go and use the JSON path to find this and take the value you see at that JSON path. Okay, so if we take this example, say this is our input, and where'd that go? And this is the JSON path, then the value is going to be 17. Okay? So what you see, the 17 here matches the 17 here. So what this is saying is I want to create a metric called arc total entries. That metric is a double metric, and the value of it is the value of the result of parsing this path. Okay? Similarly here, I want to create an arc limit, which is the result of parsing the max. Okay? So if I change this to max, I get 512. Okay? This is the simplest example. Now, the JSON parser and the XML parser are the same from the perspective of the structure. The only two differences they have is one, JSON path versus Xpath, and two, some of the operators are different here because they depend on the terminology of the relevant language. In JSON path, there is a terminology called value. In XML, it's a bit different. Okay, so that's why some of the operators are different. If you look at the wiki, you'll notice that for each of the parser, we have a list of operators that you could look at. Okay. Any questions so far?
Nothing yet on my side.
Okay. Great. So now let's start making things slightly more complicated. Here is a group operator, or groups. Look at this. Notice that the input here has multiple drives. So what we want to do is generate a metric for each of these drives. Okay. So the metric name is going to be hardware element status. Okay. And to differentiate between the drives, we add a tag called name. And the first time the name is going to be 1, and the second time the name is going to be 2. Okay. The way to achieve this is first by adding an operator called groups, which tells the parser hey, I want you to iterate over multiple entries that are all in a certain path and generate metrics for each of them. And the groups itself iterates over this path. Okay, so this essentially means I want to go start from the root and give me all the drives. So it's going to give me these. Okay. And then in the tags, I say I want to create a name tag, and the value of the name tag is disk ID. Okay, the value essentially means when you give me these elements, I want to go into the disk ID of each of them. Okay, so let's run through this for a sec. It'll be easier to see. So this is the data, and this is the initial JSON path. Okay. Okay, this gives me essentially the two drives. So it gives me an array of the two drives. Notice that the drives element and the root element are not here because I just asked for the drives themselves. Okay. Now what I'm doing is so that's what I'm iterating on. So essentially, it's going to pick this one first and then this one second. Then what I do is I say I want the value of disk ID to be the name, and I want the value of the metric itself to be equal to the status, 0 or 1. Okay. So what it's going to do is it's going to go into one of the elements. So I'll show you how that looks like. Oh, sorry, 1 second. It's like this. So it's going to go into the first element, and in the first element, it's going to pick the disk ID. So essentially what it does is it concatenates the JSON path, and it picks the first disk ID. Okay, which is 1, and it's going to use that as the name tag for the metric. And then it's going to go and pick the status for the actual value of the metric. So it's going to, instead of disk ID, it's going to put value. And that's going to be, value. Oh, status, sorry. It's going to put status. And that's going to be the value. Okay, then it's going to go to the next one and say, okay, I'm going to pick the disk ID. Just 2, and then I pick the status. The total result is going to be 2 metrics. Both have the same IM name, so the same metric name. They're going to have different name tags. One is going to say 1, another one's going to say 2. Their values are also going to be different. The first one's going to say 1, the second one's going to say 0. Okay? So let's look at an example with the command runner. Oh, did we do the command runner yet or not yet?
Briefly.
Briefly? Okay. So let's try to use this.
They are familiar.
Stick to the JSON example. Let's try to find a simple example to use from here. Actually. Fairly simple. Okay. So this is F5 LTM command runner shell parse only rest management and LTM node.imd against this guy. I'll show you the example. So this is the JSON, okay? Now what we want to do is we want to extract the different nodes in F5. So we want the status, we want for each of these guys, we want to know if it's up or down. Okay? Now notice that there are 3 states here, down, up, or user down. Okay? Now let's flip over to the parsing, which is here. And you'll notice that these are pretty well commented, so that's pretty good. You'll note, but look, there are 2 metrics here. This is one, and this is the other. Now they have the same name, and that's okay. It's okay to generate multiple metrics with the same name, as long as the values of their tags are going to be different. Okay, because if you generate 2 metrics that have the same tags and values of the tags, then they're going to overlap. But basically what he did here is he said, I want to iterate over all the items, so all the nodes, where the state is either up or unchecked, and the user didn't disable it on their own. If it's up or unchecked and the user didn't disable it on their own, I want to create a metric called LB server state with the name being equal to the full path, which you can see that here. It's basically the name of the node. Okay. And I want it to have a value of 1. Notice that he set the value as a constant instead of trying to calculate it from the field. Okay, so basically what he said here is for each of the nodes where the state is up or unchecked and the user did not disable it on their own, I want to write a metric and say the server is up. Okay. Then he also built the reverse and said I want to go over all the items, and if it's not up and it's not unchecked, or the user disabled it, notice that this is or, the user disabled it, then I want to write 0, which essentially means that it's down. Okay. If I run it through the command runner, notice that this guy, wait, which one is it? This guy is up. This guy is considered down because the user disabled it. This guy is considered down because the state is down, and this guy is considered down as well. So look at the results, and if we put them one next to the other, you'll see that don't have enough room in my screen. 1 second. App 1 is considered up. See, it's 1 here. Okay. And then the others are all considered down. Okay. So the metric name is, remember, this is the IAM name, and then the name of the actual node is within the name tag. Okay. So we if we kind of go back to the script, this is a complicated script. It's not, it's not the easiest thing to start with, but because there's this whole complicated JSON path and the logic that he put here. But it's a good example of how the JSON path can be used and the JSON parser in general. The fact that it's very, very powerful because you're going to see all kinds of weird outputs coming from devices, and you need to somehow parse them into something that our system can understand and is very standardized. And that's why we had to rely on powerful things like JSON Path and Xpath, and of course the operators. Okay.
Guys, can you set a default so if it doesn't meet any of these criteria, you'll be set to a certain?
So
you have to account for each and every possibility.
So the question is, can we set a default so that if it doesn't match any of these, can we have some kind of default value? Unfortunately, we can't. So you need to account for every single option. There is one way around that. There's something called transform, which we'll get into. But generally, yes, you need to account for every one. Notice that the vast majority of JSON parsing doesn't have this kind of structure of multiple ways of generating the same metric name. They tend to be just more fluid. Let's see if we have a good example here. This has a transform. This has a transform as well. Yeah, some of these are really advanced.
Can we do a Cisco one since we have a bunch of Cisco?
I don't know if we have JSON for Cisco.
I was thinking all that.
Oh, yeah. Yeah, I'll get to XML then in a second. Yep.
Yeah.
So I'm trying to look if there's a simpler example here. Yeah, this is probably a simpler example. What it's doing here is we have a metric called SSL secure handshakes. We are going to generate this metric multiple times by iterating over all the entries at this level. And for each and every one of them, we save its name from its description. And then the actual value is by parsing a specific path within that. So if we look at this, we'll see that what it's doing is it's going into entries, asterisk, nested stats entries, which means entries, asterisk, nested stats entries. And inside here, it's looking for this guy. Okay? And for the name tag, it's got this. and it's going to do that again. So it does that again here. Entries, asterisk, nested stats, entries, and then it goes again and pulls it. Okay? And again, I realize this is a lot more complicated than the awk parser, but it's also a lot more powerful, and it's a lot better from a performance perspective. We've discovered as well. So these parsers are really good once you kind of master them. Okay, let's switch over to XML. So let's try to find a simple one to jump into. This is awk XML, right? This has transforms. Let's see if we have one without transforms. Transform. No. Let me try to find something that's simple. Okay, this doesn't have a transform. Show pin neighbor. Okay, so the input is show IP pim neighbor. Okay, this is how the XML looks like. Now, unfortunately, with Cisco, they're not exactly issuing a valid XML. Okay, if I copy this and done this on an XML online, a formatter or verifier, let's see if it catches it. Yeah, it didn't catch it. This is illegal.
Illegal.
Yeah, from an XML structure perspective. Okay, so the rest here is actually kind of okay, except for the namespace part, which also is not exactly legal XML format. But this is not legal. So any typical XML parser that looks at this says this is bad and throws an error. Okay. So to deal with this, we had to add a special function for our friends at Cisco that is this. Basically says drop the last line. Okay. Now, like if you ask any good programmer, they'll think you're bonkers for doing this. So it's not something we like doing, but unfortunately that is the structure of the XML output. So we had to do it. Okay, so that's the omit operator you have here. The omit operator, by the way, also has other modes like regex, which we won't go into right now. But if there's a chance where you need to drop lines, but you only sometimes need to drop lines and sometimes you don't, we have a way around that too.
I have a question real quick.
Yep.
What's Cisco doing with that closing tag?
So the question is, what are they doing with the closing tag that's illegal? This little thing here, we don't know because we don't work there and we didn't ask anybody, but it looks like the end of a C data element. So in XML, there's something called C data, and you see that the C data element ends with this, okay? Closing bracket, greater than, closing bracket, greater than. So it looks like just a bug. Like whoever wrote the XML output, just somehow that happened. And it's very possible that the XML tool they test with just ignores that. But the XML library that Java uses doesn't like it very much. Okay, but essentially it's called a C data. That's what we're assuming. Okay. If we go back to this, so this is the XML. Now, in the case of Nexus, the XML is very verbose. There's a lot of text here. Usually XML is not this complicated. It's okay. But it's, usually it's simpler, and there are ways to circumvent that. But basically, this is the XML structure. And what we want from here is to get every single neighbor. So we want to iterate over this, each row in this table. Okay. So what we did is we define a variable, which in this case is /read only, which means find all the read only elements that are basically, this is how they're written, read only, like here. Where is it? There it is. So it finds this, and we define that as roots. This is just for making our life slightly easier. You don't have to do this, but it allows you to just write dollar curly bracket root ending curly bracket, and just it saves you some writing and makes it a bit more legible. You don't have to do this. You could do just the same. You could just write this. Okay, but it just makes it a bit easier. And the guy who wrote these scripts just found it very useful for him. So the metric here that we're creating is called pim state. We want to iterate over, we want to find the read-only, and then on the read-only, find the VRFs, and on the VRFs, find all the neighbors. Okay, so read-only, VRF table, VRFs, find the neighbor, that neighbor. This is what we're iterating over. Okay, so for each line that is called row underscore neighbor, we're going to create one metric. The name is pim state. The name of the device, the name tag of the pim, so the specific neighbor, is going to be the text of NBR address. So NBR address is this guy. This is the text. So it's just like the underscore value that JSON has. In XML, it's called underscore text. The reason we differentiate is because JSON uses the concept key value, so value, whereas XML calls it element and text. That's why we had to call it text. Okay, so while we created two different parsers with two different terminologies, they had a match terminology of the destination language. We can ignore these tags for now. They're relevant for this conversation, but you can see that I can even drop these, and this is enough to look at. So basically, for every row that we find, we're going to create a pim state using the neighbor address, and it's going to always be 1. The reason is that the way this protocol is built, if you can find the pim neighbor, then it's up by definition. If you can't find it, then it's down. Okay? And that's a bit tricky because you're basically saying whatever is down, I don't know of. It's tricky, and it's handled completely separately and not the scope of this conversation or this training, but this is enough. So if I were to run this, so this would be show IP pim neighbor. What did I do wrong? Show IP pim neighbor. Okay, so the result is going to show me one pim neighbor. One pim neighbor, its name is going to be this, and its value is going to be 1. So, there it is. Name is going to be this. Okay, 10.255, 20.1. And its value is going to be 1, which means it's up. Okay? Just to play around with this, let's say I do this. By the way, one of the cool things about XML is that it doesn't mind white space. So it doesn't care about it. So that's nice. So we'll do this. Set, all right, 8. I'll save it. I'll run it. Then you're going to see 2 of them. One is going to be 1 and one's going to be 8. Okay. XML, by the way, also has comments, which look like this. JSON does not have a commenting structure. You guys don't need a comment because what you're getting is input from the devices, so you shouldn't mind. But if you ever need that, JSON doesn't have it, XML does. Commenting in the parser in both cases is the same. All you need to do is just use the hash. Okay. Sublime is really nice for editing these kinds of parsers. Sublime is the tool I'm using here, just because it lines these things up, so it makes it a bit easier to see how things are in line together. Okay. That's the simple training. Now, we have more advanced operators in XML and JSON. Maybe a good idea to have another session around that. Just one second, I'll just explain what it is. But as you noticed, we've been using constant or the value or text operators to just grab the content out of the output. But sometimes you need to modify the content before you actually generate the metric. And sometimes you need more complicated metrics, like what we call complex metrics. And those things require a bit more effort and a bit more operators, and that's essentially a bit more advanced parsing. So we're going to need to have that essentially in a separate module and run through those. Questions?
Yeah, so one of the questions that came through was, you know how we're ignoring the bottom bracket, area bracket, and we're ignoring the last two lines. How come we're not just ignoring that pattern?
Okay, so good question.
If they were to fix it.
Yeah, so that's a good question. We actually have a version of that, of emit, that does that. Let's see if it was used anywhere. Looks like it wasn't used yet for Nexus. Do we have this in here? Here. So you could do omit regex. So essentially the way it would look like is this. Instead of doing bottom, you would do omit regex. See if that works. Yeah. So essentially what I said here is omit all the lines that start with these brackets and things and end with it as well. Okay, let's try to botch this just to make sure that it's doing what it's supposed to do. See, fails now. Okay, because it didn't remove this line. Okay, so start. Close all those. So this basically says I want to just omit that line, and then it doesn't have the bottom one.
Are we using that?
We were supposed to, but now that little find thing that I ran showed me that we're not. So we should, like, we could spend the time to go through it and fix all those scripts.
Gotcha.
I think there's even a ticket for that somewhere. Okay. Any other questions from anyone?
Yeah, so question is the parsing with the JSON and XML. Then which one is more easier? If the source provide both, like JSON and XML, then which one is better to the parsing? I think the JSON is better than easy to parsing.
Yeah, I tend to agree with that. That JSON is generally better to parse than XML. Unfortunately, it boils down to whatever the vendor wanted to do. Like some vendors will say, okay, we used to have an XML API. Now we built a JSON API because it's more modern, more trendy. But the JSON API doesn't cover all the stuff that the XML API used to cover, or it misses certain things, or the responses are different. So unfortunately, it's at the end of the day, it's not necessarily the technology that you want to parse, but rather what the vendor decided to expose. Like a lot of times we're going to use SSH commands and parse with awk just because the vendor made no way of actually getting this data through other formats. So that's usually what dictates. But if you can prefer JSON over XML, that's generally preferred.
Okay, thanks.
No problem.
So it just depends on the output of the device, essentially.
Yeah, depends on what the device is willing to give you. Any other questions? Over here? No.
Yeah, I think it's for the Nexus, what Ariel told us was that he started off with XML and then finding that all the Nexus platforms, they're really bad in terms of version conversion. So he's actually going back to actually undo some of that and using awk instead. So they might actually find issues like that, particularly in the Nexus platform.
Yeah.
So that's something we might have to work with Ariel and learn from his experience.
Yeah. We had the same platform, the same problem with Palo Alto. So the issue is that from version to version, the vendors just choose to change things sometimes. And it's unfortunate, right? Because it goes through, like a developer says, okay, I'm going to change it. They change it. It goes through the entire process. Nobody actually checks that part. And then you discover this 2 years later when one of the scripts break. Unfortunately, that's common. We had actually with Palo Alto, there's a specific API call that changed between 6.0.1 and 6.0.2 or something like that. And, lo and behold, our customer was running both of them. And half the scripts weren't working. And it was the same script, and we couldn't understand why not. Then we reached out to them. They explained that to us. So unfortunately, that happens. Multiple ways of dealing with that. One way is to just have both versions in the same script. Because remember, it's going to iterate over the path. And if it doesn't find anything, then it doesn't find anything, and that's okay. And what you could do is you could do this and just create two metrics with the same name. The other one just has a different path. You can say, okay, so in one of the versions, it doesn't have the VRF. And then you just iterate over both of them. It gets a pain in the butt, though, because then you're maintaining two versions of the same script within the same script, and it slightly gets confusing. And then you need to add the comments here and explain what you did. So that's one problem. Another way around this is that sometimes they only change the level in the hierarchy that the element is at. So you could just use something called / in Xpath, and then you can say, wherever it is in the hierarchy, I just want the table neighbor. So there's that way as well. But if they've radically changed it, then either having two ways of pulling the same metric, or maybe changing to awk or something like that. But even awk isn't protected because they'll change the outputs of the commands all the time. A bug we just opened to the checkpoint guy was that in one of the versions of checkpoint, they added another column in one of the commands that he's using, and that column broke his script. So you're never fully insulated from these changes, unfortunately. Any other questions? Thoughts? So the last thing is just words of encouragement. I gave them in the beginning. I'll give them again now. These parsers are more difficult than awk, but far more powerful. Once you get the hang of them, you can build really, really cool things. So don't dismay as you're hitting your head against the parsers sometimes in the beginning. After a few cycles of training, you can get some really cool stuff.